Okay, part C. The function g is given by g of x equals the integral from -2 to x of f of t dt. Find the absolute maximum value of g on the interval from -2 to 5. Justify your answer. Okay? Well, first, let's see what they gave us, because basically telling us that g is equal to the integral of -2 to f of t dt. Okay? Well, think about it this way. How do you find maximums or minimums, okay, of a function? We've done that a million times. Well, to find maximums and minimums, your critical points, you take the derivative. So basically what they're telling you here is that if I take the derivative of g, I get f of x, because you're taking the derivative of an integral. This is the fundamental theorem of calculus right here. It's saying that these two things are inverses of each other. So right off the bat, what they're telling us with this is this. And you have to say that. Like, that's part of the problem. You have to say that those are, in fact, true, that g prime is f of x. So basically, since we're finding absolute maximums, we're trying to find where this is equal to 0. Okay, so I go up here and I look at my function, and I have a 0 here, I have a 0 here, I have a 0 here, and I'm going to have to check my endpoint. Okay, so those are my possible locations of my maximum. Okay, so that's what I'm going to do. I'm going to then create a table. So I'm going to create this table. So -2, -1, +1/2, and 5. Okay, so these are going to be my values I'm going to use to find. These are my zeros and my endpoints of my function. Okay, or the zeros. Okay, so basically think of it this way. G of -2 equals, or plugging it into this function, you're going to get from -2 to -2 of f of t dt. This is one of our integration rules. If your upper and your lower limits are the same, this is the 0. So that one's 0. So g at -1 is the integral from -2 to -1 of f of t dt. So this is, remember, this is just slope. This is the slope under my curve. So I go up here. What's the slope right here? That's what it's asking me. Well, we found that in the last problem. That's 1/2. Okay. Then g at 1/2. And again, this is going to be the integral from -2 to 1/2 f of t dt. So again, so this is 1/2, this is -1/2, this is -1/4. So this is -1/4. And then the last one, g at 5, if my board will help, is the integral from -2 to 5 of f of t dt. And gosh darn it, if we didn't already find that. We found that in part A. So if we go back over here to part A, we found this right here. That's our answer, 11 minus 9 pi over 4. So we come back over here, part C, this is 11 minus 9 pi over 4. So 11 minus 9 pi over 4. So which one's the biggest number? Well, this is your minimum. -1/4 is your minimum, so that can't be it. 11, so 9 pi over 4 has to be just bigger than 1/2. So let's just round this to 3. 9 times 3 is 27. 27 divided by 4. At max, that would be like 8. And 11 minus 8 is definitely bigger than 1/2. So this is my maximum. That is my absolute maximum. And all you have to say is basically, after that, you've shown your work. You just have to say the absolute maximum on G between -2 and 5 is at x equals 5, and G at 5 is 11 minus 9 pi over 4. And that's just for necessity. So this problem is just using the areas, okay? So basically you're just evaluating this integral and the area under the curve to find your g values based on the equation that they gave you, okay? So it's really quite simple if you know exactly the notation that they're giving you.